So while people are still coming in, I will just give a brief introduction of what I'm doing. So first of all, thanks for the organizing committee for letting me to share with you some findings of what our lab is doing. So I'm from the University of Reading, and this is where I'm doing my first postdoc training. And this particular project, we examine the influence of motivation on decision. So I'm quite sure most of you are familiar with this tale. So why did Pandora open the box even after she got a warning from Joseph, the king of all gods according to Greek mythology? Why did she waited for Epimetheus to fall asleep and break open the box that released all the misery and trouble into the world? A story like this one, I don't actually know the moral of the story, but this is an example that makes me think sometimes in real life, we also let our curiosity that to influence our decision. So motivation affects behaviors. Existing literature examine decision-making primarily with extrinsic incentives, for example, money. However, literature research focuses on the influence of intrinsic incentives. Curiosity as an intrinsic motivation supports a wide variety of intellectual activities. For example, it has been shown that curiosity predicts academic performance above and beyond intelligence. It also enhances long-term consolidation of learning. In particular, in a study conducted by Gruber and his colleagues, in the experiment, they assess memory performance using trivial questions as a stimuli to generate curiosity. Trivial questions and answers include details and facts that are usually considered amusing, but at the same time, we are not quite sure about the answer. This generates a knowledge gap, which is a common definition for curiosity in the field. In this particular study, the authors showed that in the immediate and delayed memory test, participants have better performance for relevant information learned, which is the answers to trivial questions, and also incidental materials that are the phases they were exposed during the states of high curiosity. Another important findings from this study is that they have shown that curiosity is related to reward processing, which is reflected by the enhanced activities in the brain's reward system during the states of high curiosity. However, this study only focused on the influence of curiosity on memory, but not decision-making. In our current investigation, we are interested in knowing whether curiosity influences our decision-making, even when participants are facing the potential risk, which is induced by electric stimulation. We also want to see whether there is a shared neural mechanism to support the influences of both curiosity and extrinsic motivation on decision, which is the tendency to take risk. So in our experiment, we have two types of stimuli. I'm going to show you some magic tricks videos we are using. So we use magic trick videos to induce curiosity because it's generating a knowledge gap. So we are quite curious about what's going on, how magic works. And the other types of stimuli we're using are food images as extrinsic motivation. So do you want to know how it works? So I will tell you at the end of the talk. So inside the scanner, participants perform this task. They were presented with either magic trick or an image of food one at a time in random order. In the decision phase, they need to make a decision to either accept or reject a bet to take risk of receiving electric stimulation in order to get a reward after the experiment. So the rewards they are going to get includes solutions in the magic trick trials or the actual food item after the experiment. Immediately after they make a decision, they will receive a feedback or come back to it later. But what I want to stress here is that this paradigm has been tested with a separate group of participants outside of the scanner. So in the decision phase, they need to make a decision to either accept or reject a bet. So this pie chart is buried in terms of the probability of how much participant will get shocked versus how much they may get the reward after experiment. And so after they make the decision, they will see the outcome. If they accept, they will either win or lose, or they can just reject to pass. Before the experiment start, participants actually experience an electric shock because we need to identify the maximum electric threshold. And after experiment, they need to rate each item in terms of how curious they want to load the solution to the trick or how much they want the food. So I'm going to show you the behavioral result, which is model from the participant performance. The behavioral performance assess a model with a general linear mixed effects model. So if you look at the graph on the left, across the x-axis, when the probability of shock increase, it's not really that surprising. Participants would tend to accept less, but what we think are more interesting is if you, for example, focus on the probability of 50%, with a more interesting stimuli, with a more interesting magic trick, participants tend to accept more. So you can see the curve shifted to the left. And then in the case of the food, you can also see like just focus on like 50% with a more desirable food item. It's actually make participants to accept the bet more. So we show that curiosity, the magic trick, and desirability of the food actually predicts individuals' tendency to take risk. And this result, we were able to replicate this result with a separate group of participants outside of the scanner. With the fMRI data, here I'm going to present to you a result from a 2x2 ANOVA analysis at the decision phase. So the category include magic tricks and food, and then the choices we split it, the trials in which participants accept and also the trials participant rejected. We have found main effects of choice across the stimulus type. So with accepted trials, when compared with rejected trials in both food and magic, we have found greater activities in the encaudates and midbrain parts of the brain reward system. And if you look at the bar charts here, so the effect size in food and magic. So for both accepted trials, for the accepted trials in both stimulus type, they are much stronger compared with the rejected trials in a cluster encaudates. But we haven't found any significant activation for the reverse contrast or further interaction effects. So in this data, we don't show any specific activation or mechanism for a particular type of stimuli. So in the previous model, analysis model, the result could be confounded by the probability of shock. So we tested the result with another parametric moderation model, including the choice as a regressor and then the probability as another regressor, and we're still able to show similar activations in the reward network, although the cluster are smaller after controlling for the probability of shock. I may skip this, but interestingly, if we just look at the probability of shock itself, we show the related activations that can be found in the insular in cuneus. So insulars all are traditionally associated with the coding of negative states in the aversive stimuli. So as a summary, we show both curiosity and desirability of food predict tendency of risk-taking on top of expected probability of getting electric stimulation. We also found a shared mechanism in striatum that supports the role of curiosity and extrinsic rewards in influencing individuals' decision to take risk. Thank you for your attention and curiosity for this talk. And just want to say thank you to the PI, my supervisor of this project, and other members in our lab, the funders, and my previous PhD supervisors. Thank you.